Welcome to EDU World Space.
Hi, everybody. So, knowing the amplitude of the motion of the element, we need to find the combined constant K and B the damping factor. So for this, what we need is to find out the frequency. In here, we're given as 2 pi n 60, and this equals 2 pi 1,200 RPM divided by 60, and that gives us 125.664 radians per second. And we also are going to need the mass, which is the weight divided by gravity. And the weight here is going to be 300 pounds divided by 32.2 feet per second squared, which equals 9.3167 pounds second squared divided by feet. Okay. And now we can solve for A, which is it wants to know the K constant. And we can find that through this equation right here. Okay. Okay, come on. Soon as my pen gets back on here, there we go. Okay, so we have that. Get your C omega F divided by your K, which is the K constant, minus M omega F squared. Okay. And so we're actually just going to look at this because the phase difference is going to be pi 2. So we're going to set this equal to 0. And we don't have to worry about anything else because the phase difference of pi divided by 2 results in this equaling 0. So from that, we're going to get K equals M omega F squared. And now we can plug in the information we have. So 93167 pounds second squared feet, okay, equal times, almost forgot this, 125.664 radians per second, and this whole thing is squared, and this equals 1,147.1173 pounds per feet. Okay. Or we can say it is 147 times 10 to the third. Or even better, we can actually say it's 147 kilopounds per feet. Okay. Now for B, oops, did not mean to go down that far. Now for B, we have your X M equals PM divided by K minus M omega frequency squared. This whole thing is squared. Okay. Plus C omega frequency squared, square rooted. And this thing equals 2M, your P equals 2MR omega frequency, okay? And this thing is going to equal 0. And because of this, we end up with XM equals 2MR omega frequency divided by C omega frequency. And let's see. Oh, this is actually squared here. Okay. And we need to get the C over here. And because of this, we get, there we go. We're going to get C over here divided by 2mr omega frequency. It's just 1 because this cancels out that xm. Okay. And now we can plug in the values that we have. So the value that we have is 0.0271. And the 2771 actually comes from, and I didn't write it, it comes from your mass equals weight times gravity equals, and this is just the teeny one, which is 0.875 divided by 32.2. And we get this, okay? And times 6 inch divided by 12 inch. And we get 125.664 divided by the xm, which is also 6 inch divided by 12. And these cancel out. So for this C, we get 68.28 pounds second feet. Okay. And now we need to find the CC, and that is 2 km. And that's a capital M, so that's the M that we found earlier. So 2 times K, which is 147 times 10 to the 3 pounds per feet. And this is 3 times 9.3167 pounds second squared feet. Okay. And now we get 2,341.5148 pounds second feet. Okay. And now for the damping factor, which is what they wanted for this problem, we got C over C. So we get 68.28 divided by 2341.5148. And let me make that 68 a little bit better looking. There we go. And we'll divide it. And again, the units cancel each other out, so we don't have to write it. And it's going to be 0.0292. And that is your answer, okay, guys?